All right, so I'd like to wrap up our conversation of polynomials, addition, and subtraction by looking at an application. Some of the stuff I'll discuss right now is a little bit advanced, but just, again, I really want to make it really clear that, there is a reason why we're actually adding and subtracting fractions polynomials. And so this is basically my quick look at what this does. So I think most of us are familiar with the fact this is a business application, that the profit I make in dollars, right, is equal to the amount of money that we bring in minus the amount of money that we basically take out. Right. So revenue is usually made by producing an object and then selling that object. And so it turns out that revenue, put simply, right, if we let X equal the number of objects that we're selling or items that we're selling, and they could be anything. Maybe they're toy trucks, maybe they're books, maybe they're dresses, their pants, whatever the case might be, right? The price of the object times X, right, is what the revenue is. So let's just say, again, let's say we're talking about shirts, right? The number of shirts that I have, if I sell them for $10 a shirt, right? That's how much, you tell me how many shirts I sold, I multiply it by 10, and that's my dollars of revenue that I made. All right. And of course, there's other sources of revenue, but, just in a real quick way, it's usually the price of the object multiplied by the number of objects that we had. All right. And in chapter 11, we'll actually get deeper into this. But for an example, let's just say our revenue function was a quadratic, say something like -1/4 x squared plus 80x. All right. So I'm just trying to do a working example. So it's a quadratic because it's degree 2. All right. It's a higher order polynomial. All right. So a degree 2 polynomial. Cost is a little bit easier to explain, right? So let's just, for my working example, let's say the cost is 10x plus 30. Usually our cost, there's a variable cost and there's a fixed cost. And the total cost is usually the sum of those. The variable cost, you notice that it's used to multiply by the number of objects that we have or the number of items, is how much it costs me, all right, to produce that one item. So again, I reuse the number 10, but let's just say for each shirt, it cost me $10 to make the shirt, right? So those are the physical costs. A fixed cost are things that are not dependent on the number of things that I make. If I rent out a facility, possibly paying my workers, whatever, some sort of fixed budget item, the amount of printing that our company has, it could vary from topic to topic. So that's basically our cost. So I guess, again, figuratively gave us a revenue function and I gave ourselves a cost function. So how do I find my profit from this, for the number of items that we're going to produce? Well, my profit, let's just call that P, is my revenue, -1/4 x squared plus 80x. Let me put that in parentheses. Take away the cost. So from a working example, that's what that would look like. And you notice what we're doing is we're basically subtracting polynomials. A degree 2 polynomial, take away a degree 1 polynomial. And so what we've learned in this section is we're going to distribute that minus sign. So my profit that we're going to make based off of this model is -1/4 x squared plus 80x minus 10x and then plus 30. All right, and if we can combine like terms, my total profit function is -1/4 x squared plus 70x and then plus 30. All right, and so we can now mathematically model how much profit I presume to get if I tell you the number of objects that we're going to produce and sell. All right, so let's just give ourselves a figurative number here, right? Let's just say that we want X to equal 100. We're going to produce 100 t-shirts or whatever the case might be. So how much profit do I make? Well, we're going to plug in that 100. So we're doing an evaluation for X. And my profit function basically tells me how much we're going to get. All right. And so if we square 100 right, that's going to be 10,000. And if we take 70 times, that's 7,000. I'm having trouble writing my sevens here. I'm getting used to writing on an iPad, so hang with me, right? 7,000, right? And then plus 30, alrighty? And then negative 1/4 times 10,000, I believe that's negative 2,500. All right, so break up 10,000 into quarters. So negative 2,500 plus 7,000 plus 30. If we add these two guys together here, we get negative 2,500 plus 7,030. And then off to the side here, I'm going to do this subtraction by hand, right? That's what that's going to look like. So we get 0, we get 3, we got to borrow here, that we get, right, 5, and then we get 4. All right. So what we end up with is $4,530. All right. So that would be the profit that I would earn if my model was that way. And more importantly here, what you have is an application, in this case, of subtracting polynomials, right? So, of course, when we get more complicated for costs, we're actually adding, there's a cost 1 figure, right? There's a cost 2 figure, there's a cost 2. So perhaps to get my total cost, we're adding cost. And you can also see that there probably would be an addition if we had more than one item. All right, so that basically gives us an application of this, a little bit of evaluation practice as well. All right, so that wraps up our section 4.4, how to add and subtract polynomials. Pretty easy. We're just basically combining like terms along with an application that we'll get deeper as we learn more math. All right, thanks for your time, and I'll see you guys in some videos coming soon in more modules. Take it easy.